Hello, good evening and welcome to another exciting episode of Debuggering Flummery. Tonight we will be investigating issue number 100, wherein French FBX files cause Flummery to crash. Let's jump straight in with Flummery and import ourselves a French FBX, lecube.fbx. Straight away it's crashed with an unknown data type error. And the data type it does not know about is number 4. Right, when investigating an issue like this, where we're reading a binary file, it is very useful to look at the binary data directly. So we use a hex editor to do that. I like to use HXD, which I have here, and I've already got lecube open. So, very first thing we need to do is find where in the file we were up to. We do that by having a look at our binary reader base stream position, and we'll convert that to a hex offset. There we go. So we were up to 38BD. Let's jump to that offset in here, 38BD. There we go. So this is where the file has been passed up to. Now we need to work backwards and find out what went wrong. Back over to our code, and we will scroll up this switch statement to find out what happened just before. Right, so it switched on data type. 4 is an unknown data type, and so it went to the default. There's been no reading within the rest of this method here, so let's look at our call stack and jump up a level. We can see right here, read byte, that's where the number 4 came from, and it's looping through a collection of properties and adding them to an element. It successfully added 2 of them, a very large number of some description, and a string, boit, I think, 001, : model capital S. Now this capital S is giving me a hint as to what's gone wrong here, because it should end with model. There should not be a capital S on the end of this. What we'll do is we'll jump back over to our our HXD here and see what's going on. So if we have a look at this, so ignoring the 04 for now and looking at the previous entry, we can see in 53 here, followed by an integer, which in this case is hex 10, which is decimal 16. And if we select 16 characters, we can see BO weird A registered trademark symbol TE001 ... model. So we can see 16 bytes needed to have been read, but for some reason it has read 17 bytes, which meant that the next byte it read was this instead of this. So what we need to do is investigate why that happened. So let's have a look. What we're going to need to do is exit out of this processing and place a breakpoint. And we'll make it a conditional breakpoint that says when the base stream position equals, and let's find out what we need it to equals. We need it to equals 38A6. So we'll type 38A6 there, and then we'll stop this and fire it back up again and re-import the FBX file. Here we go. Import FBX lecube. This will take longer because conditional breakpoints is having to evaluate that variable every instance, and that is called a lot. And we could have made it quicker by not converting it to string and testing the string values, but I'm not very good at well, there we go. It's done. So if we have a look now, if we step into this, what we're expecting to happen is it will read this first byte here, passing 83 into our read data dictionary method, and we'll follow through from there. So we'll step in, yes, and as we can see data type of 83 as expected. So let's step down here into 83. Okay, what's going to happen now is it will read an unsigned integer, which will be this value here, and then it will pass that value into this br read property string. So let's have a look. Right, there we go. So we've passed in the number 16, and this should read 16 characters from the file. A character is usually a byte, so we would expect it to read that much data. So let's carry on and then investigate this array. Ooh. Right, so BO special I. See, what we'd expect to see here are two bytes worth of data, not one. And if we scroll down to the bottom, we can see the capital S. So what's happened is the read characters has actually read the Unicode data for us instead of the individual bytes as were written into the binary file. And so while it's read 16 characters, it has actually read 17 bytes of data, and that's why everything's out of sync. So the solution to this problem is actually very straightforward. What we'll need to do is stop this processing and change this to be read bytes. We can't put bytes into a character array, so we'll have to change that. But now we see we can't do this anymore. What we'll have to do is actually populate these two positions with the decimal value of a colon. The decimal value of a colon is 58. So let's pop a 58 in there and a 58 in there. We also can't build a string out of a byte array like this. In order to build a string out of a byte array, we need to do encoding dot utf8 dot get string, and we'll pass in our byte array. And that should do the trick. So let's find out if that works. Fire up Flummery again. Takes slightly longer because it's having to compile this time. There we go. And let's go File, Import FBX, Le Cube, and oh, I forgot to turn off the breakpoint. We don't need that anymore. So, oh, there we go. Look, imported straight away. No problems whatsoever. So it was the fact it was reading 17 bytes in order to read the 16 characters. Now we have loading working, we should test saving, because usually when there's a loading issue, there's a saving issue to go with it. So let's export this to LeCube export now and see what happens. There we go. Data misaligned exception. So somewhere in the saving code, it's basically generating the same kind of problems we had when it was loading. There are two places we're going to need to investigate as part of FBX saving. One, where it's calculating the length of a section, and two, where it's writing the values themselves. The length of a section is calculated within this here, the calculate offsets method. It sums up the size of all of the properties within all of the elements, and that is your overall size there. So let's see how that works. As we can see here, when the way it calculates the size of a string property is simply by taking the length of the string. But now that we know these strings can contain Unicode characters, which are 2 bytes per character, this is incorrect. A 15 character string containing 1 Unicode character actually weighs in at 16 bytes. So what we're going to need to do is actually get the proper length of the string. So we need something like that. That will do the business there. The other place with FBX saving that we'll need to look at is where we actually write the values themselves. So if we scroll up a little further down here, we'll see we have a string write method, and again this is writing simply the length of the string as the number of characters. We will need to do something similar to above, so we'll do system text encoding UTF-8 get bytes. We'll pass the string in there. Now with those two corrected, we should be able to fire this back up again, import the French FBX, export it again, and it should work. So let's find out. There we go, just firing up Flummery. File, import FBX, le cube, in. File, export FBX, le cube export, out. And the final test, file, new, file, import FBX, le cube export, and in again. Problem solved.